kind of excited. I haven't done this one in a while. So let's see what we have. First of all, we have circle O. So this is definitely the center of my circle. It says that all of these guys are tangents. So in other words, basically anything that looks like a tangent is. And it gives us this fun fact that DH is parallel to AC. So that is definitely going to come into play. We're definitely going to need to look at that and use that eventually. And then we're just given two arcs. So we have BC is 70, and I'm going to put this in pen so that I remember for sure positive. I didn't make that up. That was actually given to us. And then also that DE is 22, and I'm going to put that one in pen as well. So those guys are that. So I always like to just kind of start off simple. I know that that's 22 because it is equal to that arc there. What else do I have? I know that angle 23, this whole angle here, is equal to 90 because this here is my diameter. So I know that that's equal to 90 degrees. Let's see what else I have here. I know that this is 70, so let's go ahead and get angle 6. This will be 35. Well, let's see. If this is 70 and this is 180, that would make this 110 degrees here. What else do we have? Well, let's look at this. This is the tangent. And so my 21 is half of this arc. So I can get this as 55. And 19 is the same thing. And let's see, that means that this one by triangle equal 180. This one would be 70. So let's see if that helps me any. I think now we can use our parallel. So I'm going to make mine kind of some color here. I have this parallel line and this parallel line, and I have this transversal. So that puts me that angle 8 and 21 are equal to each other. So this is 55, and if this is 55, then this here is 35, because remember they added up to 90. And if this is 35, this is 70, I think this is it. And then this is 70, I have every other arc here, which makes that guy equal to 88. So that was the kicker. We needed to know that they were parallel and to use this transversal. We needed to use the fact that this one gave me this one here for my brain part. My semicircle, my 180 degrees, so that gave me my 110, and then this one was half of that. So that's kind of the big part. Now that I have every arc, it's just a matter of making sure that I don't do anything wrong. So 10 is half of this arc here, which is 55. Let's see, 17 is half of this arc here, which is 35 here. I know these are linear angles, so this is 125. Let's see. Well, this is an isosceles triangle, so because these guys are both radii, so that means these two angles are equal. Subtracting from 180 and dividing by 2 gives me 79 and 79. Let's see. This one here is not half. This one is not a tangent, so I don't get to do that one for that guy. But what do I have? Let's see. If I look here, this angle is half of both of those guys. So 110 plus 170 is 180 divided by 2. So these are all 90, which is superbly fantastic. So I am 90, 90, 90, 90. Some of you had probably hoped it was, and now you feel vindicated because you're right. Let's see. These are linear angles, so I can use 158. This angle here is half of this mess. So 110 plus 22 divided by 2, which would be 66. And then this is a quadrilateral. So I can just use a quadrilateral equals 360 to get that that's 46. What else do I need? I need this. If I look at this, this is 180 plus 22 minus 70 divided by 2 is 20. And then I get my 160 because they're linear. And this one here is all this mess, this whole thing. So 110, 22, and 88 all added together. And then subtract my 140 and divide by 2. And that gives me 40. I think the only one I'm missing is 22, so I've got this little mess going on here. So 70 plus 70 minus 22 divided by 2 is 59. All right, so this was the kicker. How to use that and how to use this guy here. Those are the two magical ones there. Very cool.